This is Ritesh Srinivasan and welcome to my channel. Salesforce introduced XGen, which is a 7 billion large language model, and it is trained on 8K input sequence length. So we will first try out the instruct tuned model of Salesforce Xgen. It is available on HuggingFace. We'll try out a small summarization task and then we'll come back to some details on XGen. Okay. So here's the Salesforce model card for Xgen7 8K instruction fine-tuned model. These are released by Salesforce AI Research and these are for research purposes. Okay. So we can try out this model. So I wanted to try out in Collab first, but then I was running out of memory. So I wanted to run it on a GPU instance. So for that, I am making use of jarvislabs.ai. So they have GPU instances. You can sign up and then you can, start spinning out GPU instances very fast. Okay. So in my case, I created an instance over here by selecting, a 6048 GB graphics card and increase my disk space to 140 GB. And I said, launch the GPU. And this instance got launched, right? And it's been now running up close to an hour, right? And this is the cost incurred till now, and I can launch a Jupyter notebook. So I've launched a Jupyter notebook, right? And then I install transformers, LangChain, and because I'll be using a LangChain prompt prompt template over here for generating the summary. So then what I do is that from LangChain I import a HuggingFace pipeline. And I also import torch, and from transformers I import auto tokenizer, auto model for causal LLM, and pipeline. And then I just copy the tokenizer and model instructions available over here, right? How you can use this model as autoregressive samplers. One thing you need to be a little bit careful about is that this uses tick token from OpenAI for tokenizer, so you need to install that. So actually I've installed it over here, right? And then here I create my tokenizer and model for the Xgen7 8K instruction fine-tuned model, right? And then I create a pipeline over here for text generation task, right? This is standard HuggingFace pipeline, right? And my precision is bfloat 16, right? And then what happens over here is my model is downloaded, right? It was previously downloaded, that's why it's not showing over here. It was downloading 3 chunks of 9 GB each, right? And then it loads the model. I'm not sure why it is 3 chunks of 9 GB over here. Typically in a 7 billion parameter model, it might use up to 14 GB of graphics memory. But in this case, it is using more. Okay, that's why I couldn't run it on a Collab, because the CPU memory in Collab was 13 GB and this was fast and it was exceeding it, even though the GPU was 15 GB. So then I tried it on this instance, because this instance has 32 GB of main memory. Okay, so this is how I instantiate the pipeline, and then I create a LLM chain I create an LLM, basically the model as HuggingFace pipeline, pass the pipeline, and model args, I pass the temperature is 0, right? Then from LangChain, I import prompt template and LLM chain. And my template is like this. Write a concise summary of the following text delimited by triple quotes basically. Return your response in bullet points, which covers the key points, and then I have my text as an input variable and bullet point summary. So my prompt is prompt template. This is the template and input variables is text, and I create an LLM chain with this prompt and the LLM instantiated over here, which is the Salesforce Xgen7B-8K instruction fine-tuned model. Okay, so then I just copied the text over here from this particular blog on this release, right? So I copied that and I say and I just wanted to generate a summary. So what I do is that I copied the text and I say print LLM chain.run text. It took sufficient time for generating the result, a couple of minutes. Okay, little more than a couple of minutes, and this was the summary which was generated. 7 billion large language models named XGen are trained up to 1.5 trillion tokens and 8K sequence length. XGen models are fine-tuned on public domain instructional data, right, creating their instruction-tuned counterparts, which is what I'm using now. XGen7 billion instruction training details It generated some kind of summary over here, but I'm not really satisfied with this summary. Maybe my template needs to be a little bit better over here. Okay. But then I said, okay, let me try with another text. And here I gave some text pulled up from Wikipedia on Tesla. And this is my text. And I say print LLM.chain.run text1. Okay, this is that new text or Tesla. Here it generates a decent summary on Tesla like this. Tesla Inc. is a US based company. As of 2023, Tesla it pulls out a decent summary over here from the Wikipedia page of Tesla. Okay. But it also generates some other text. I think the prompt template needs to be a little bit better for my summary to be generated in the way which I want, because it has generated a bullet point summary over here, but there is also another bullet point summary over here which comes out really well, right? So if you want to extract from this output, probably you can extract after this bullet point summary. So here is the summary. It says Tesla is American electric vehicle battery energy storage solar panels, right, maker, and it pulls out a couple of lines beautifully from that text, and it generates this text. This summary is quite satisfactory. Okay. Then there is another text which I talk about Apple. Again, I've pulled information from Wikipedia. So here also, if you see, it pulls up a couple of lines as summary, right? Or it generates couple of lines. Pulls up is not the term to be used over here. It basically generates. It's a generative model, right? Text generation. So it generates. It's not an extractive summarization. It is generative. So it generates a summary over here. It has actually generated decent summary up to this point, and then it goes like, is this a good summary? Would you like to make revisions attractively? Summarize the text. Some other additional text is also getting generated. I see this as an issue with the way in which I've created my prompt template. Probably if I change my template and try it out, probably I might get better results. Okay. So this was about using the Salesforce Xgen7B-Instruct instruction model for summary generation, using LangChain. Here they've given a very simple, code for, prompt, right? Article, insert a document over here, basically your text, and prompt is like this: human, please summarize the following article, and then you get the output from the assistant. Okay, so this is the reason why you are getting this assistant text over here, because this has been trained like that. Okay, so probably in my prompt also, if I were to put human and then the prompt, and then the response which I get from this this thing is from the assistant. That is why you are seeing this assistant coming up in some of the responses. Okay, so this is the response actually, right? So you can extract from this assistant over here, from that piece of text, from that piece onwards. So this is the summary actually which has been generated, which is quite good actually over here. Okay, that was an oversight which I did not check when I copied this code and I was trying it out. Probably I had to have this human in the prompt and the reply comes from the assistant. Okay, so this is interesting. Now let's go to the paper quickly. The blog, basically they also have a paper, right? If you go to the blog, here is a kind of key takeaways. This particular model achieves comparable or better results when compared to state-of-art open source larger language models like MPT, Falcon, LLaMA, Redpajama, OpenLLaMA, right? And the targeted evaluation on long sequence benchmarking, modeling benchmark shows benefit of 8K sequence models, because this can take input up to 8K sequence length. Okay, and it has been trained on 1.5 trillion tokens, right? And this also achieves strong results both in text and code, benchmarks. A training cost of $150K on 1 trillion tokens under Google Cloud pricing. Okay, that is the training cost for this particular model. And here they explain about why 8K sequence length. Right, you require long sequences because you want applications like submitting long text, right? Writing code, predicting protein sequences. So this requires a model to consider long structural dependencies. A large context allows a pre-trained large language model to look at customer data and response to useful information seeking queries. So that's why they wanted to train it on, longer sequence length. Right, so here they give an example of like the details of these models. So Xgen7B 4K base is trained on 800 billion tokens with the sequence in 2K tokens first, and then another 400 billion tokens, total 1.2 with 4K. It is also released under Apache 2.0. The 8K base is actually trained on 1.5 trillion tokens with 8K sequence length. On top of this, 400B on 4K length and 800 billion tokens of 2K tokens, additional 300 billion on with 8K sequence length, right? And then the instruction tuned version of this has been fine tuned on instructional data like Databricks, Dolly, Bayes and GPT related data. This is released for research purpose only. This is not for commercial use, but these two are for commercial use. Okay, because it's Apache 2.0. And here they talk about the two-stage training strategy where each stage uses a different data mixture, and this is the first stage of 1.37 trillion tokens, and this is the data mixture of the various data sources. I will not go into it. Okay, and the second stage is for code generation tasks where they mix more code data from star coder with data from stage 1. Okay. And then they have given details of training details and other things over here. Probably I'll not cover those things. You can read the particular blog. I'll be putting it in the description of the video. So you can check it out over here. Here they compare it with the various benchmarks, right? And how this is better than all the other models. That's what they're saying over here. Okay. So I'll be putting the link to this particular blog. You can check it out. So this is an interesting new large language model, and it is available in HuggingFace for you to make use of it. Both the base models as well as the instruction tuned. Instruction tuned is only for research purposes, but the base models can be used and fine tuned for your downstream tasks. I hope this video on Salesforce Xgen is useful for you. If you like the video, please like, share, subscribe to the channel. See you in another video.